Okay, here's your second video, starting off with problem number 6. This reads that y equals the natural log of x squared raised to the 5th power. Okay, so if I were to read this out loud, it would indicate that we take the natural log of x squared times the natural log of x squared times the natural log of x squared 5 times. So you got to deal with the 5 before you deal with anything else. So let's see, that means that y prime then would equal, the 5 would come down with 1 less power. Here's your brick right in here, natural log of x squared, and then that brick has to disintegrate out here, right? So the derivative of the natural log of x squared is 1 over x squared, notice it is a chain rule also, times the derivative of what dropped to the denominator, which is 2x. Okay, so now you guys should be able to simplify this. This 2x is over 1, the 5 also over 1. So what can we combine? Okay, we can combine this 5 over 1, that's to the 1st power, the 1 over x squared, which as a chunk is to the 1st power, and the 2x, which is to the 1st power. Okay, so let's get to it. Y prime equals, technically you could put this over 1. If you multiply straight across, 5 times 1 times 2x gives me 10x. Okay, so you get 1 times x squared times 1 gives you an x squared down here. And then you have the natural log of x squared to the 4th power. That's going to go in the numerator. Okay, so you're almost there. Notice the x should cancel in the numerator and denominator. So this equals 10 natural logs of x squared to the 4th power all over x. All right, so there's number 6. Let's move on to problem number 7. Okay, 7 is a little bit more straightforward. 7 reads that c is equal to 5 natural logs of 3x minus x squared. All right, so when you take the derivative of c, again, your instantaneous rate of change, your slope generating machine, you pull the 5 out and you have at it 1 over the quantity after the natural log. So 3x minus x squared. Don't change that chunk of information. This is certainly a chain rule. So then you multiply by the derivative of the brick, right? That brick has to disintegrate. 3 minus 2x. All right, I'm going to allow you guys to finish that one off. Your answer should be at the end of these 21 problems. All right, let's jump now to problem number 8. Okay, so for problem number 8, we have capital F of x equals 4 minus e to the negative 2x, the quantity cubed. All right, so again, you'll notice that this does take 4 minus e to the negative 2x times 4 minus e to the negative 2x times 4 minus e to the negative 2x. So this 3 is driving this problem. So we have f prime of x, which equals, bring the 3 down and square it. Here's your inside, don't touch it. 4 minus e to the negative 2x times, now that brick has to disintegrate. Notice there is a wall right here between these two. So I'll take the derivative of 4, which is 0, minus the derivative of e to the negative 2x. Notice it is an e, so copy e to the negative 2x times the derivative of this power, which is negative 2, right? That takes care of everything. Okay? So capital F prime of x then equals 6 times 4 minus e to the negative 2x, quantity squared. Okay, let's move now to problem number 9. All right, so for 9, we have y equals, I'll move that up for you, 4e to the 3x squared minus 4x. And actually this is cubed, 3x cubed. Some of these are a little difficult to read. If you are having difficulty, shoot me an email and I can tell you what it reads as. Plus e cubed. Right, so here we go. Y prime equals, pull the 4 out, and we're gonna copy e to the 3x cubed minus 4x times the derivative of this power, which is 9x squared minus 4. Plus, notice there was a wall right here. So I have to do this one separately. Plus, now I'm gonna copy e cubed down times the derivative of 3, which is 0. Right? So when I simplify it, I'm only gonna have this first term because the second term ends up being 0. And that should make sense because e is approximately 2.718. So e cubed should still be a number, which means its derivative should be 0. So there's 9. Let's do one more. And that's problem number 10. So c of q equals 2q plus 1 over 3q squared. All right, let me rewrite this. So this equals 2q plus, as I mentioned, leave the numbers alone. 1/3. Now you can move your variables, so I'm gonna make this q to the negative 2 power. Okay, so now I'm ready to take the derivative. So then c prime of q equals the derivative of 2q. If it's a number of variable, then it's just the number, plus 1 over 3, and I pull the number, the power down, and q to the 1 less power, like that. Okay, so then c prime of q then equals 2 minus 2 over 3 q cubed. All right, so let's see what's going on here. That 2 is over 1, so notice I get negative 2 over positive 3. That's what's going on there. And this q was to a negative power, drops it to the basement or the denominator. Okay, we have enough time for one more problem, or at least the start of it. We're going to look at problem number 11. This is very similar to a problem that I just did. Let me make sure that I have enough space. P of t equals the natural log of t divided by 2t plus 1. Okay, if you go back and look at your quotient rule notes, you should notice that there's one problem that I did by itself that is very similar to this. So I'm not going to do this one in its entirety, but I will start you off. So p prime of t, again, if I read this out loud, it says the natural log of t divided by 2t plus 1. So your natural log is the main thing because it's being applied to this quotient. So let's get to it. The start of this is 1 over t divided by 2t plus 1 times the derivative of what's in the box. Sorry, so I'm going to cover this one up because we have to focus on the box. So here we go. This is a quotient rule. Low, 2t plus 1. The high, which is 1, minus the high, which is t, the low, which is 2, all over 2t plus 1, the quantity squared. Again, please go back to your notes and find that video that I did a problem that was very similar to this. It should say something like the derivative of a natural log and quotient rule. That should be the title of the video.